Okay, in this video we're going to look at how to solve some algebraic equations. The first question says the rule to find the nth term of a sequence is 8n subtract 3. Use this to find the 15th term in the sequence. The 15th term is, well, we'll take the number 15 and make it our input. We will replace the n with the value of 15. So it becomes 8 times 15. And multiply always takes precedence to subtraction, so we'll go ahead and multiply 8 times 15 first, because in this case the 15th term is replacing the nth term, hence why we substitute 15 for n. 8 times 15 is 120. Subtract 3, and then we should be able to work out our output. 120 subtract 3 is 117. So that's our answer, 117. Now, that's a pretty simple question where we have to substitute a particular value. In this case, it's 15 for the nth term, and we put it into the rule. So I wrote the rule in the table, and building a table is an important strategy to solving these questions. Let's look at a slightly more challenging question. Okay, this question says the nth term rule for a linear sequence is 2n plus 5. Which number does not exist in this sequence? No, the number something does not exist in the sequence, and it gives us some of the outputs. So in this case, it's important to understand that the numbers 31, 53, 78, 85, they are indeed actually the outputs. So we need to plug them into the outputs, put them through the rule, or reverse them through the rule, and see if they are a legitimate input, see if they remain a whole number. So our input rule output would have looked like this. So we would have put a number in, the nth value would have been multiplied by 2, added 5, and we would have got 31, 53, 78, and 85. However, what we're going to do this time is we're going to reverse the rule. So I'm putting the output as the first column. Now I'm doing the opposite. The opposite to adding 5 is taking away 5 from the number n. The opposite of multiplying the number by 2 is dividing by 2. So I have reversed the rule. I'm going to put some numbers in and see if they work. And the first one I'm going to investigate is 31, because that's our first number on the rule. So it's 31. So what is 31 take away 5? Well, 31 take away 5 is 26. Divide that by 2, and it becomes 13. So does that make sense in this case? Yes, it does. So that's a valid input. And what about 53? So let's investigate for 53. Subtract 5 becomes 48. Divided by 2 will give us 24. So again, that looks like a valid input and output number. The next number to investigate is 78. So let's do 78. 78 subtract 5 is 73. Now we have 73 divided by 2. Now that is not going to give us a whole number. That's going to give us the number 36.5. So we have identified, by the looks of things, the number that is not a valid input and output. In this case, we look to have identified 78. So I would propose 78 as my answer. Now, what I would do before I finish this particular challenge is I would investigate 85. I'd put 85 in. 85 subtract 5 will give me 80, and 80 divided by 2 is a pretty easy calculation. It's 40. Your handwriting would be a lot neater than mine, so yes. So the numbers 31, 53, and 85, they're all legitimate input and outputs to this number rule. However, number 78 has been identified as not being a legitimate input and output. So the steps to solving this are: look at your input rule and output, reverse it, put the output at the end, completely flip the rule around, and then see if it works its way back to give you a legitimate input.